In this circuit diagram, we need to find the Thévenin equivalent circuit with respect to the terminals A and B for the circuit. Our terminals are located right here. We have a couple of resistances here and also a voltage right here. We need to find VTH and RTH. This is our current problem. In previous problems that we've done, playlist linked below with all of them, we have found the Thévenin equivalent by doing the previously mentioned node voltage method that was talked about earlier in chapter 4. Like for this problem as well, and not for this problem, but for the past two problems, we use the node voltage method. But for this one, we are going to strictly stay to source transformation, especially because of how simple this problem looks. We know what a Thévenin equivalent circuit looks like. This is in the notes linked below in section 4.10, but I'll draw it out here just for reference. This is what our Thévenin equivalent circuit looks like. That's what we need our circuit right here to look like for us to solve for our VT of H and our RT of H. So to start this, I am going to use the source transformation, and I'm going to look at this part right here with our 80 volts and our 10 ohm resistor. We know that if we rewrite this using the source transformation, we can put our 10 ohm resistor in parallel with our 30 ohm resistor, and then we can, instead of having a voltage over here, have a current. So to find this current, we're going to say that using Ohm's law, I is equal to voltage over resistance. We know that our voltage is 80 volts and our resistance is the 10 ohm resistor. If we solve this, we're going to get that I is equal to 8. So we are going to have I is equal to 8 amps right here. We know our voltage is going from positive to negative, so our current is going to be going the opposite direction like this. Next, we can combine the two resistors in parallel. So these two right here, we're going to use the formula for resistors in parallel, which is 1 over the first resistor plus 1 over the next resistor, and this is all being raised to the power of -1. If we do this, we are going to get 7.5. So for our resistors in parallel, we have 7.5 ohms. I'm going to redraw this so it's a little bit easier to see. I've redrawn this here. Now looking at this, it is almost close to our Thévenin equivalent circuit. However, not quite yet. We still have a resistor in here, and this needs to be changed to a voltage. Well, that's perfect. We can actually use the source transformation for current instead of voltage this time. We know if we do that, on our left side, we are going to have a voltage right here. To find this voltage, we are going to look at the current and the resistance right here. Voltage is equal to current times resistance, so we're going to have 8 times 7.5. This will give us 60. So we are going to have 60 volts right here, and this is from plus minus. Now our 7.5 ohm resistor is going to be in series, and this is just because of the source transformation rule. It's going to be in series with this 2.5 ohm resistor, and once we've written this, we can easily see that if we just combine these two resistors in parallel, we are going to get 10 ohms of resistance. And this is exactly what this Thévenin equivalent circuit looks like. So this, we'll just plug into here and see that it's our answer. We're going to have 60 volts for our voltage and 10 ohms of resistance. If you have any questions about the material we covered, you can leave them in the comments below. If you want more introduction to circuit analysis, there will be a playlist with the full coursework as well as the notes in the description.